Alrighty, this is going to be a bit of a random video. I'm going to try to explain how my portal system works. I'll start by mentioning that I'm not using stencil buffers, I'm using render textures because A, I didn't know how to use stencil buffers, never used them before, and B, I'd heard that it can cause issues with rendering some effects in Unity. So I guess I'll just start by demonstrating the portals. I've got it set up so you can left click to place the portal 1 and right click to place portal 2, and then you can walk through them. It's basically perfect. I don't think I've seen... That's not true. Occasionally I do see a slight Z fighting issue. I'll get into why that happens a bit later, but mostly it doesn't. I've managed to avoid it for the most part. And it is infinite. Let me just push this cube out of the way. Okay, it is infinite. I mean, I can just keep walking through them. The red square at the end that you see there, that is when I am rendering the first recursion, which is the furthest portal away, the deepest portal. I start by clearing the texture to red so that we don't get Hall of Mirrors. Eventually I'm going to make it render a closed portal texture just so it looks a bit nicer, but at the moment it's red so that I can see it. Oh, and the other thing is I recently got working. I can now dive through portals, and it doesn't quite work like Portal does. It currently rotates the camera as well, so if I'm looking that way and I go through, it'll do that, where in Portal if I'm looking that way and I go through, it'll do that and leave the camera facing the way it was if it can. You can jump into them like this, and it does work, but for some reason you gain momentum. I'm not quite sure why. Also, I'm just noticing now that I'm coming out on a different angle to how I went in. That's a bug. I'll have to figure out why. It does work. This system does work with physics objects. I don't have a way to pick them up yet, but I will. Just maneuver this cube over. The only thing it doesn't do yet... Okay, there's two things it doesn't do yet. Is it doesn't render the shadow objects, the copies that you have to have on the other side of the portal, on the receiving portal, to make it look like it's halfway through. It doesn't do that yet. That's pretty simple to do. I just haven't got there yet. The only thing is when I push it through, it will portal, if I can get it to go through. But what happens is, because I haven't gotten around to making it rotate the velocity to match, so that because the velocity is in world space, so if it's coming into this portal here, it's going that way towards the portal, and then it comes out of this portal over here, but the velocity is still going that way. So it just immediately portals back again and just gets stuck going backwards and forwards. I haven't fixed that yet, but I will. So pretty much it. Yeah, you will see this error come up sometimes. If anyone knows what actually causes that, I can't figure it out. I've spent way too long trying to fix that, and I have no idea what's causing that yet. It doesn't seem to actually affect anything. I haven't seen any problems that arise from that error. I don't see any glitches in rendering. I don't see any missed recursions in the portal. I don't know. It has no effect. So, pretty much, when you click, let's start there. When you place a portal, create portal, this is on the portal manager object. It just instantiates the portal prefab and tells it to initialize, and then adds it to its portals array. Okay, let's have a look at that portal prefab. This is the portal prefab. It has a lot of parts. It's not that complicated to understand what's going on. The most important part is the render plane. This is what you see when you look at a portal, mostly. This is just a plane with its pink. That's just because it is assigned no material. When it's instantiated, if we go to the portal script up here, the plane is assigned a new material, and so it's a cube. Now, the reason for having a cube is because if we didn't... I wonder if I can show this. I wonder if we just disable top hat mode. Okay, this is what will happen for most people when they try to do a render texture based portal. You get your portal, you go up to it, and then you're like, oh, wait, that worked perfectly. Why did that work? Okay, I've figured out what's going on. To demonstrate this, I have to disable this as well. Actually, let's just disable the rest renderer. Right. So this is what will happen to most people when they try to do a render texture portal. You'll walk up to it, and then, oh no, what's this? This ugly grey band. What you realize pretty quickly is that you are clipping through the plane, and I'm actually seeing behind where that portal is placed. So out there, that's just there. I'm just seeing straight through the back of this cube here. This is actually pretty simple to fix, but it's a bit difficult to explain. Let me just re-enable this code here. When you get close, actually I know what I can do. I can do a new game tab here and just drop that there, and then we can go back here. Now we can see what happens. Place a portal here and a portal here. Now when I get close, what actually happens is the portal plane disappears. Now we can see the portal plane has been hidden, but instead we now have behind it this cube with the face removed, the front face removed, and with the normal facing inwards. And that just means that when the camera gets really close but hasn't portaled yet, this cube is rendering. To make it render on top of everything, it uses its own camera up here, top hat camera, and it's called top hat because I'm picturing it like a portal. The portal plane is popping up like a top hat. It's going like that, and it renders over the top. It clears the depth. It renders after the main camera, and it renders only the top hat layer. So that's how I handle the clipping issue. Right, let's go back to the portal prefab. So back in the portal prefab, we have the cube. This is the render top hat. I should probably call it that. Render camera. This is the camera that will render what this portal sees. The way I think about this is I think about everything for this portal that's contained in this portal prefab is for this portal only. The camera is what this portal sees. The triggers are for this portal. Now, when it comes to rendering portals, the way you have to think about this is that, say, this is a portal looking that way. The palm of my hand is that front of the portal. It's looking out that way. And this is the other one. It's looking out that way. If I have the main camera looking into this portal, it should be looking out this way. The way you think about that is that the portals should be back to back. Imagine them being stuck back to back, and that's how the maths for positions and everything works. So when I have a camera in front of portal A, looking into portal A, on camera B, I should have a camera behind portal B, looking out of portal B, because when you stick them back to back, the cameras will be on top of each other. It's a really poor description, but I hope you get it. What I commonly relied on was drawing portals in Paint. So we have portal 1, portal 2. We have a camera here looking into portal A, like that. I notate the front of the camera, portal, front of the portal. That's the front of portal A there. The front of portal B is facing down. So the camera looking out of portal B will be roughly like that. And then portal B's render image is displayed on portal A. At some point they have to connect to each other. You can't just have everything completely self-contained, one portal only doing its own portal things. They have to talk to each other. So I guess I'll just go through what happens when you place a portal. The first thing it does is initialize. We just create a new material for the plane and the cube, the top hat cube. And we assign it a shader. Now the shader is how, because if we just take what the camera sees and we place it onto a portal, there's lots of explanations better than mine, better than I can do online for how to do this, how to think about this, but pretty much if you take what a camera sees and just squidge it all onto the single plane of the portal, it won't look right. It'll be squished and way too small, and you won't have the right perspective or anything. So instead what we need to do is take what the camera from the other portal is seeing and render that in screen space, and that's just what that shader's doing. I didn't write the shader, but yeah, it just renders the render texture in screen space, which is why if you go into a game and place a portal or two and now come back into the scene view, you can see it's like stuck to the view because that's it just rendering in screen space. Oh, that is very odd actually. But you can see if I go up to it, this is what the camera is seeing. It seems squished. I don't know why it seems squished, but it's correct. Yeah. And then after we've given them materials, we create a new render texture at the current screen width and height, so that the camera for this portal, which is this camera here, is rendering to that texture. Then we set top hat mode to false, which just hides the top hat cube, because if we didn't, since it renders over the top of everything else with the top hat camera, if I do that and save it, it'll look fine from the front because we'll have the render plane in front of it like this. Looks fine until we go around the side or we have something else move in front of it, and you can see what it's doing. It's just rendering those cubes over the top of everything. So that's why we have to disable top hat mode when we are not close to the portal. Now, this is where I recommend you check out this video. This is a video by one of the guys from Portal that created Portal 1 that worked on Narbacular Drop, and one of the guys that worked on Portal 2. And this video, he explains really well how they handled the physics of walking through a portal. So what it does is when the portal is created, we do a physics overlap box. It uses the size and position for the box of this far trigger object here, which is quite large, and it just detects any colliders that are touching that box or within that box, and does add collider to object. What that does is using this library. This is just a port of CSG.js, which isn't perfect. It creates some very dodgy looking polygons, but it works well enough, and it's fast and easy to use, very simple, and I needed a mesh boolean library and this worked. So pretty much we just get all of the colliders that are within that far trigger area and do a boolean intersect with anything that's in there, and we end up with whatever colliders, in fact I can show you, whatever colliders were touching that far trigger. So this is the far trigger for Portal 1, Portal 0, and these are the colliders that it was touching. So we have a bit of the floor there, a bit of the wall, and there's a reason that the far trigger is slightly behind the portal. And the reason is that if it weren't, when we were colliding with the colliders of when we're colliding with these colliders, we would have no collider for the wall here. So we have a bit of the wall and a bit of the floor, and then from there we use this hole punch object, which has a mesh but it's hidden, and it just sits a very tiny bit in front. You can see just there in front of the portal, and goes back into the portal a bit. It doesn't need to go that far. It only needs to go as far as far trigger goes behind the portal. That's as far as it needs to go, but it goes further for no reason. And it just cuts a hole in any colliders that are, it just does a Boolean difference on any colliders that are within it. What this gives us is a copy of all of the colliders around the portal with a hole. So now, since we're still colliding with the world geometry, this world geometry still exists. We can't just remove it. So what happens is we use the close trigger. When an object, or in most cases the player, gets close, touches, intersects with this close trigger, they switch layers. We have quite a few layers because it's a bit complicated to get everything to collide correctly. This is how I've got my layers set up at the moment. When you get close to the portal and you touch the close trigger, you the object is placed into the portal 0 or portal 1 close objects layer. And I'll just show you if I go back into here, just place this portal back in here. When I get this close, now the player will be just slightly intersecting, oh, no it won't, this, oh actually, completely inside this close trigger, which means the player object is now in the portal 0 close objects layer, which means it is not colliding with default. 0 close objects does not collide with default, which means now we are colliding with our custom tiny section of the world that has a hole in it so we can walk through. But what happens, I hear you ask, if there's something blocking the portal on the other side? Since we're colliding only with the stuff that's in front of the portal and we can walk through, what happens if there's something on the other side? Well, as it happens, this world here is part of my experimental Sauerbraten Cube 2 styled Octree world editor, which means I can just place down a barrier like that, put a portal in behind there, and another one here. Now, I can't walk through it. Why can't I walk through it if we're only colliding with the colliders in front of it? Because we're not. In addition to the local colliders, not sure what's going on there. Don't look at that. In addition to the local colliders, we also have the linked local colliders. These are a copy of the local colliders from the other portal, rotated behind this portal, so that it's as if we were trying to walk out of here and running into this. And you can see there's the L shape here of the cubes that I built in front of the first portal. That's how we handle the colliders, the static geometry colliders. When I get to implementing the physics objects like this cubette here, it'll have to be a copy of the whole object, including the rigid body and its collider, and the shadow rigid body will have to be on a joint or just manually applied forces to try to get it to be in the same place as the other one. And it'll just have to simulate having the cube be in two places at once. There's not really a better way that I know of to do that, but it's fairly simple. That's how Portal handles it, and that works okay. So, we need to render the portals. This is mostly just trying to wrap your head around where the cameras for each portal need to go. So, the rendering for the portals is controlled by the Portal Manager object. This one here. In order to prevent Unity just automatically rendering the cameras, we have the camera component disabled. And then on late update, which just means that everything else has moved, all the positions are good, physics has happened, everything's happened. Now we render what you see through the portals. This means there's no one frame lag or anything yucky like that. It looks perfect. We first record which portals are in top hat mode and disable it, because when you're looking through from a different portal you'll never be close enough that you need to be rendering with top hat mode, and if you leave top hat mode on, then obviously you'll see it from the side and it'll render over the top of things and do weird things like that. So we disable top hat mode for each of the portals, tell each of them to render recursion number of times, max recursion number of times, which in my case is 8 times, I think, 8 times. I can set that as high or as low as I want. If we set that lower, it starts to look a little bit rubbish. So it actually looks pretty good there, and with a closed portal texture or a copy of the texture or something, it would look better. But if we lower that down to, say, 82, oh wow, down to 2, now you can see quite clearly when the recursion, when you transition through the portal. Let's just see what happens if we go to 100. How poorly does that run? Quite poorly. But for all intents and purposes, it may as well be legitimately infinite because you can't see that far. 8 is a good number for testing, I think. So it goes through the recursions, and it doesn't just do all of Portal 0's rendering and then all of Portal 1's rendering, because if a portal can see the other portal, then they need to take turns rendering so you see each of the recursions. So in the render function, we first figure out where the main camera is relative to the portal we're rendering, and position the rendering camera for this portal at the same position but rotated around this portal's position and its up vector by 180 degrees, so it's facing out the other way. Then we get the portal rotation. Now, in order to render the recursions correctly, it needs to look like... So this is how I figured out what the cameras should look like. It's just with paint. So imagine this is the main camera here. This is Portal 1. After the render camera for Portal 2 has been positioned and rotated 180 degrees, so it's now in the same position but reversed locally to this portal. What we need to do is basically just continue the pattern of the offset between the portals, not between the cameras. Initially I tried doing the offset between the main camera and the portal, but that is not correct. So you do the difference between the portal's position and the rotation. So pretty much it figures out the offset between the portals, and then for each recursion that we're on, starting at the 0th recursion, we start at the furthest, the deepest portal render. So what I can do to demonstrate this is if I actually break after the first render, what we can do is place portal here and a portal here, and it didn't work. What did I do wrong? Okay, if I break after the first recursion, what you'll see is that it is a really long way away. This is... So actually I can show you in the scene view. My main camera is looking that way. It's looking out that way. Which means that... And this portal here is using the texture rendered by the camera from this portal. Which means this portal's camera is way back there. And then for each successive recursion of the rendering, it'll reduce... If we go back to this script here, it'll reduce the amount that it moves back by until it gets just back to the first position. So it'll go here, then it'll go like here, then here, then here, then here, and eventually it'll render here, and it'll render on top of each other, on top of the last one each time. And it will end up looking correct. If we just remove that. Eventually it will render until it looks right. While I was figuring out the positions for the recursive renderings of the portal cameras, I determined that I needed a way, because there's only one camera used for each portal to render everything. It just moves the camera each time and then renders again and moves in renders and moves and renders. And I needed a way to see where each of the cameras were going, so I created this really dodgy system which just instantiates, for each time it renders a camera, it just instantiates an object in the place of that camera, and that object has it'll just get removed the next frame. So it's really slow and dumb, but it worked. So we can see in the scene view, because we're facing this portal here, these ones are facing the wrong way to create any useful render for this portal. So what do we see? Is it just all grey? It will be all grey. Earl Grey even. Yeah. If I were to turn around, then all the camera positions here would be rendered correctly onto this portal here. So we can see that they render in points along, which the distance between them, between each render, is the distance between the portals. And then if I place one portal here in the middle of this one and one here, you can see that I'm looking through this portal here and then through it again, but from a different perspective. If I just pause this, it'll run faster. So the first render that we see on this portal here is from this camera. The one further away is from this camera. Yes, this is correct. From this camera, and we can see the wooden block here is what we see here. And then if you could see, if it didn't go round so far, it feels on less of an angle, and you could see the portal again, this is the angle you would see it on. You've probably noticed that there's a lot of grey in the rendering from the portal cameras. This is because in order to not render... Okay, let me just demonstrate this. This is probably obvious to anyone that has tried to do portal things before, or has looked at any tutorials before. If with the cameras out here, my main camera is facing this portal here, which means we're seeing what these cameras are rendering. If we actually saw what these cameras are rendering normally, we would see this, which is the back of this portal surface, which is not useful because we want to see out here. We want to just see through that. So in order to fix that, the cameras have their near plane set to the back of the portal. So for where this camera is here, its near plane is here. It's in line with this portal here, so nothing behind that gets rendered. It's like having a really far forward near plane. And it's an oblique near plane frustum, because if you just try to set the near plane to the distance between the portal and the camera, if the camera is off center at all, you'll get all kinds of weird gross clipping, and it just will not look good. I believe it is this is where we set the clipping plane. We just it's actually really simple. All you do is get create a plane class object using the render plane's forward position, and then I've got a bit of an offset which helps with Z fighting, and then we just do some magic maths which I don't understand, but it works, and then set the calculate an oblique matrix, set the projection matrix using that. The reason I do it from the main camera is because calculate oblique matrix seems to rely on modifying the existing projection matrix, and I got some weird errors that I just couldn't find the source of until I realized that it made randomly the clip plane would just not work properly, because what I was doing previously was just render camera dot calculate oblique matrix, whatever it is, like that. So that is roughly how the rendering works. There's a lot more details than that. So I'll just go on to how traveling through the portal works. It's very simple, really. I just have, so that I don't have to have a different script for each object that I want to be allowed through the portal, I just have a base portaling handler script, and then anything can inherit from that, extend that class, and override the main methods, do all the work. Pretty much what it does is, because we have in the portal prefab a trigger that is on the portal cross trigger layer. It's just a flat box collider at where the plane is. Every fixed update for any object that has this portaling handler script It just does a line cast from its last position to the current position and checks if it has crossed the portal. And if it has, pretty much it just gets the offset of the object from the current portal and moves it to the same position on the other portal, but rotated 180 again around the other portal's up axis. And then I just have a player portaling handler, which has some special case things to handle the kinematic character controller, which is a fantastic asset if you ever need a character controller. You don't want to make your own. It is really good, and that's pretty much how it just goes through portals. So we have the portal manager, which handles creating, removing, linking, and rendering portals. We have the portals themselves, which basically control all of their own stuff, and when they're told to render, they figure out, based on the index that we pass in from the portal manager, they figure out where the camera, how far back the camera should be. They don't handle setting themselves to top hat mode. The camera itself does that, I think, somewhere. Yeah. Now, you may have noticed, if you're really smart and watching closely, that anything that's in the close objects layer can't collide with anything, all of the regular stuff outside in default, or whatever the regular layers are. This is so that when the object goes into the portal, if you had the portal on a really thin wall, for instance, and another physics object behind that, it doesn't hit that object through the wall. But it also means that anything, if you had, say, if this was the close trigger here, the close trigger there, and some physics object just barely touching it, this physics object is now in the close objects layer because it's touching the close trigger. It would mean that anything here, for instance, wouldn't collide with it. So instead, I have also the far trigger, which looks like this. Anything in the far trigger collides with both the regular world, default, ignore raycast, all those layers, and objects that are in the close objects layer and in the far objects layer. So far objects here collides with everything except the local colliders, because these local colliders are special. You only collide with local colliders when you're in the close objects layer, when you're very close to the portal, in that really, really small box, this black box here. And this here is the portal just here. Little orange portal. Hello, orange portal. This means that objects that are in close collide with only objects that are in close objects, and objects that are in far objects. And when they're touching close objects, they don't collide with the main world static geometry. They only collide with the custom small copied version with the hole cut out. And pretty much this will mean that everything will still collide with everything that it should. And it also means that if I have an object behind, let's pick a color you can see, behind here, like this, on the back of the portal, it can push as hard as it wants towards the portal, but because it's not touching the close objects trigger, it won't be able to go through the hole, because it's only colliding with the regular world geometry. Now, you probably have noticed, when I go through a portal, even if it's level with the ground or very close to it, there is always a very slight hitch, and that flickering there is because I've got the debug camera still turned on. Very slight hitch as it goes through. I think what's happening is that the character controller is resetting some velocity things when I tell it, when I do its set position on it. And I'm just going to have to try and figure out how to handle that. I do correctly rotate the velocity for the player when they come out of the portal. I tell it that on its next update tick, it should rotate the velocity basically, so it's coming out the right direction. But it still comes out with a slight hitch, and I think it just must be something the character controller is doing. haven't figured it out yet. I will at some point figure it out. So yeah, I think that basically covers everything. If you have any specific questions, I'm quite happy to answer them. Just ask in the comments or in the Reddit thread that I will link in the description. It's simple. It's not simple. It's straightforward in concept, but getting your head around how to handle this is, I find, the difficult part. And also trying to figure out the maths. Like, I wasn't super familiar with quaternions before I started doing this. I've made a utilities function just so that I could do quaternion subtraction, so to speak, without forgetting which way round they go. Yeah, this has been a very long and rambly, random video, but hopefully it sort of helped some people understand how I'm doing it, the general ideas behind how I'm doing this. So yeah, ask questions if you have any questions, and I will see you later.